Now what we're going to do is we're going to dive into a more complex scenario where we have a producer that produces events that will later go into a big scale data engineering pipeline. So step one is we're going to make a Lambda function that will grab some events from a DynamoDB table. In this case, it'll be a bunch of companies. It'll read those events in, take those events and place them inside of SQS. SQS is a queuing service that can handle an infinite scale. And those events later will tie a second Lambda to, and it'll process those events in the queue. So step one, let's go ahead and set up SQS queue. So I'm going to go here and go to simple queue service. Next, what I'll do is I'll create a queue, and I'll call this one producer. And I'll make it a standard queue. And what a standard queue does is it has unlimited throughput. So basically, by being okay with some of these trade-offs like at least once delivery, best effort ordering, what I get as a result is that I actually get an infinite scale. So I don't have to worry about overwhelming this queue. So I'm going to select quick create queue. There we go. I have a producer. If I want to test what it's like to send a message, I can use this interface here, queue actions. So I'm going to go send a message, and I'll just say test. I'll make a very simple message here. Once you do that, you'll see that those messages will then populate in these fields. So if I say refresh here, you can see that this message is now available, and I can go and I can view or delete those messages. So I'll go to that and I'll say start polling, and here you can see that message, it appears. And now what I can do is if I wanted to, now that I've read it, I can delete that message. And once I've deleted that message and I close this, you'll see it now it says 0 messages available. Another thing you can do as well, if I go to queue actions here and I'd say test, and then let's say I make another message, I do test 2, and it'll have a couple messages. When you're testing, you also can purge the queue. So if you have a bunch of messages that you want to get rid of, you can go to queue actions and you can say purge queue, and this will just get rid of the messages in there so you don't have to worry about them. But in general, this is going to be the high scale queuing system that we're going to populate with messages from our producer. So this producer, it's going to get its data from DynamoDB. So let's go over to DynamoDB and set that up. So step one is I'm going to go to DynamoDB here. And what we're going to do is we're going to create a table. In this case, I'll just call this test table. And for a primary key, this is really the only thing you have to do other than make the name of the table. It needs to be some kind of globally unique identifier. You can't have the same key twice. If I say GUID, globally unique ID, it goes through and it creates that test table. Now I've already got one created called Fang here, so I can let that one churn away here. And if I go to Fang, what this has in there under items is it has a bunch of companies' names. So I have Facebook, Google, Microsoft, Netflix, Oracle, right? These are all company names here. And what I'm going to do is I'm going to have a Lambda function scan this entire table, pull that information out of DynamoDB, and actually send that information to SQS. And we're going to use the technique that we explored earlier where I'm going to call that function on a timer. So really that's the first part of our serverless data engineering pipeline. Okay, so now that we know that those names exist here, and again, if you want to see how to create a name here, it's very simple. Let's just take this test table. If I want to create a new name here, I can say, Google, like that, and it's that easy, right? So really straightforward to create new things in DynamoDB. So next, let's see here. I've got the table, I've got the queue. Now let's go back over to Cloud9 and let's set up our ecosystem. So I'm going to go again to my AWS Resources button here, and I'm going to select this icon, Create New Lambda, and we'll call this serverless producer. And if I go next, I'm going to select for runtime Python 3.6, empty function. We'll go ahead and say next. For trigger, I don't need any trigger. I don't need to build an API. I'm going to say no. If I go next here, I will need to set a role that has the privileges that allows me to read from DynamoDB and also put messages into SQS. Typically what I do when I'm developing Lambdas is I'll create a administrative role that gives me the privileges so I don't have to go back and forth, and then later I'll go back and I'll tighten it up in production. So here's an example. I can say choose an existing role, and I have a role called admin dev for Lambda, right? And so I can go through and rapidly use this to talk to other services in AWS. So I'll say finish. Once I do that, then I can go over to this Lambda interface over here and create a new function. So what we'll do is I will go to that Lambda that I just created, and this is called serverless producer. And I'm going to pop into this serverless producer and look at this Lambda function. There it is. Close this. And I'm going to just paste in some code that we'll walk through. So the first step here is that I use the Boto3 library, and that's the SDK for Python for AWS. Next, I import the JSON library to do some JSON handling. And then over here, I set up some global variables that give me access to different resources that I'm going to use throughout my Lambda. So I have a DynamoDB resource that I talk to via Boto3, and that allows me to read data from DynamoDB. I specify the table here. That was the Fang table we saw earlier. I also have the producer right here in this variable, and then I also create an instance to SQS. So really I have two instances and two variables. Then what this Python JSON logger does is it sets up logging for me so I can get structured logging that'll appear in CloudWatch. And this is really a best practice of DevOps is to have instrumentation on logging. Next, what I do is I have a function here that scans a table. So line by line, what this does is it first makes an instance of DynamoDB so I can talk to it. And then what I do is I do a scan. And what a scan does is it just says, give me every single thing that's inside of that table so I can have access to it. I take those items and I then return them. Next, I create a function that allows me to send individual messages to SQS. So what I do is I go to SQS here and I grab the queue, and then I send a message into the queue, and once I've sent the message, I'll return back the response, what I get from sending the message. Finally, this function here, it wraps those two things together. So I go through that DynamoDB table, and for every entry in the table, a 1-to-1 ratio, I send that entry into SQS, and it becomes a message, right? So if I have one company, there'll be one message. If I have two companies, there'll be two messages. And here's now where I get to my timed Lambda, is all it needs to do is run that one line of code that says send emissions. It is able to talk to DynamoDB, and it's able to talk to the queue. And again, this is triggered on a timer. So now that that's all set up, I can save it. And one final thing that I'm going to need to do is I'm going to need to set up Boto3 and also Python JSON logger, because those are third-party libraries. To do that, what I'm going to do is I'm going to cd into this directory and set that up. So I'm going to cd into serverless producer, and then I'm going to cd into the subdirectory as well. And actually, before I cd into there, I'm going to need to source a virtual environment. So whenever you create a new Lambda, it'll give you a virtual environment in Cloud9 that I can develop with. So I'm going to say source venv bin activate, and then I can change into that lower level directory. And now all I need to do is install these two libraries. So what I'm going to do here is I'm going to do a pip install, and then I'm going to do -- target, which allows me to specify where it's going to install the target, and I'll do ... So basically, install these third-party packages one layer above me inside this directory. So I'm going to say pip install Python -JSON -logger, and that should work. And again, that installs it one level up. And then I'm also going to install the Boto3 library. So we'll go through here, we'll change that, and we'll do Boto3. And once that's running here, one of the things that we can do that's pretty powerful is we can tap into our ecosystem in Cloud9 to test this out, right? Because there's a lot of stuff going on. I have to scan a table, I have to take the messages out, I have to put them into SQS. So what I can do is I can go back to my AWS Resources tab here, and I can find that Lambda that I set up, which again here is serverless producer. If I right-click on this Lambda function, I can run it. I'll say run, and I'll say run local. And what run local does is allows me to run it as if it was running inside of AWS, but I can run it inside my development environment. What I'm going to do here is I'm going to now scan DynamoDB and also send messages to SQS. So these will appear in SQS and we'll be able to find them. Okay, let's go ahead and run that. If we look at these server results here, you can see that it was able to actually run that, and now you can see as well, these are all server-based log files that show that it's acting on SQS and it's acting on DynamoDB. So I can go back now to my cloud-based environment, and if I go to, let's say SQS, there should be, let's say 8 messages or so. And in fact, I do have 8 messages. And if we look at what those messages are, they should be company names. So let's go verify that. If I say view messages, let's pull those messages. And in fact, they are. Name Facebook, name Google, name Netflix. Great. So we know that that's working. And if I want to test it again one more time, I can run it again. It'll be 16 messages. So let's run it again. Okay, that looks like that's working. Let's go back again to SQS, and there should be 16 now. Great, there's 16 messages. So I know that that is working locally. Now, really, the only thing I need to do to get this running inside of AWS is deploy, and we've already done that. So I'll go through it and deploy. We've done that previously in lessons, but I'll do it again here. So I'm going to go down to this icon here. I'm going to right-click on it, and I'm going to say deploy. And again, within just a few seconds or so, it's going to take not only the source code that I just wrote, but it's going to take those 2 third-party libraries I installed, package them all together as a zip file, and put them inside. And at that point, we're pretty close to being done. The only thing that's going to be left is we'll probably want to test it one more time inside of the Lambda environment, which we'll do. And we'll also want to verify that the CloudWatch timer that we're going to set up is going to trigger it every minute. So step 1, let's go into Lambda here, and let's just verify that that deployment was successful. Okay, so I go here and I type in serverless producer. Here we go. It appears, right? We see 20 seconds ago. Next, what I can do is I can just test this out. So I'm going to say test, and I can just say, sure, hello world, right? Because this is not going to take a payload. It can be any payload. And I'm going to go ahead and run that. I'm going to say test, and it should do the same thing that we saw locally. It should put a bunch of messages in SQS. Let's see if that is in fact happening. Yep, here we go. It's putting a bunch of messages into SQS for us, right? So now I've got it working inside of AWS as well. And if I go over to SQS now, and let's go here, let's go to SQS. SQS should have 32 messages or 24 messages, right? And so it keeps getting bigger. And if I run it again one more time, it's going to have 32. If we go back here to SQS, right? So great, I've got a full pipeline working. The only thing I don't have working is the automation on the timer. So let's fix that. So to do that, we already went through that process. I just go to add trigger, and it's trivial. I go down to CloudWatch events, and I find that 1 minute rule. Again, for development, I would highly recommend using 1 minute, but then in production, using an hour or a day or something like that. So we go to 1 minute timer. Great, that all works. I'm going to make sure I enable that trigger. I say add, and now it's going to run automatically. So what's going to happen is I'll wait about 60 seconds or so, and this queue, without us doing anything, is going to grow larger. So it's at 32. It's going to be at 40 once that other one hits. So I'm going to wait for a second here and go back to CloudWatch logs so you also can see in real time what's happening when this Lambda is called. So if I go to monitoring, I can look at all the different events here. I can see how many times it's successfully called, how many invocations there were, and I also can look at the logs in CloudWatch logs. Here we go. If I go to this log here, we should see a bunch of messages, right, where it's talking to SQS. It's grabbing messages from DynamoDB. It's sending messages, right? So I have a great history here of all these different actions that were lined up here in that Lambda function. So, and again, what's so powerful about the way I'm logging it is I'm logging it in a key value format, so I can do structured queries on those log messages. So it looks like probably 60 seconds has passed. So if I go back here again, this should now be a 40. Let's see. There we go. So we know now that this Lambda is being called on the timer automatically. And if I just leave this running, it's going to grow bigger and bigger and bigger. So that's really part one of getting your Lambda working inside of a producer-based workflow where you have something that's called on a timer. It doesn't have to be what we just did. It could be, again, many, many different things. It could be, moving petabytes of data, doing machine learning, calling into Alexa. There's a lot of different use cases, but the key components are serverless plus a timer.